Hi everyone. So I am back. So this will be part two of the challenge lab creating a dynamic website for the cafe. So I was accidentally stopped the recording. So this is gonna be the part two continuations for this lab walkthrough creating a dynamic website for the cafe. So where we left off is we are here in this step. So in the search box service, into the service, right? AWS Service Management Console. We're going to go to Cloud9. Go to AWS Cloud9 Console. In the environmental page, notice that the cafe is a web server environment. It indicates that this is the type of EC2 instance. So go back there. What I'm going to do is go to Cloud9. It's already right here. So go in Cloud9 and go to AWS Cloud9 console. In the environment web page, we notice this web cafe web server environment, cafe web server environment right here. Awesome. And then we just want to choose open right here. So you are now connected to the AWS Cloud9 IDE that is running on the EC2 instance that you observed earlier. The IDE includes the bus terminal on the bottom right panel, a file browser on the left panel that shows files in like home EC2 user environment directory on the instance. The file editor in the upper right panel. If you double click on a file in the file browser, such as the readme.md file, it's going to display in the editor. For example, such as this, if we click like readme.md, it's going to open here. So go back where we are. So on task 3, analyzing the LAMP stack environment and confirming that the web server is accessible. Recall that the objective of this challenge lab is configure an EC2 instance to host a new dynamic website for the cafe. In this task, you will analyze what is already installed. So observe the OS version. So in the AWS Cloud9 bus terminal, we are going to run this command right here. Awesome. It shows our Linux versions and metric, things like that. So notice how the output indicates that it's an Amazon Linux instance, roughly analogous to the Red Hat 7. Observe the web server database and PHP details and server state. So in the terminal, we're going to run this command right here, line by line. So first, we run that command. Secondly, go to this command. Okay, after that we're going to run this third command right here. Finally, we're going to check the PHP versions. Awesome. So the output show the versions of the web server and the database, and also show what they are not currently running. To start the web server and database, and also set them to start automatically after any future EC2 instance restore. So in the terminal, we're going to run this command right here. This is the first one. Second one, third one, and we will install database. This one. Now check the status. Awesome. So configure the EC2 instance so that you can use the AWS Cloud9 editor to edit the web server files. Notice that the AWS Cloud9 file browser currently does not display the Apache web server default web directory. So in the terminal, we have to run these two commands right here. First one, the second one. Awesome. So the first command you ran create a symlink from the default AWS Cloud9 editor workspace to the var www directory that contains your web server files. The second command changes the ownership of HTML subdirectory so that the EC2 user, which you are now logged in as, can edit and create new files in it. Creating a simple test page. So in the 5 browsers, right? you're going to do this, expand the cafe, web server, AWS directory, and highlight the AWS, the HTML directory. Highlight the HTML directory. Go to file and create new file. And create new file. We are in here. Let's create new file. Oh, yep. Put it down a bit. Okay. And then in the text editor, what we're going to do is we're going to paste this in here. And then we're going to choose save file. And then we're going to save the files as index.html. Okay, file, save file as index.html. Awesome. Very good. Now make the website accessible from the internet. In this step, you will need to verify the update. What I'm going to do is in AWS. Wait, what are we first doing? EC2 instance, right? EC2 instance. This is EC2 instance. And Cloud9, how to so access is to service in AWS console, right? Click. So let's see what can we do here. So first of all, verify the public IPv4 to access the EC2 service. It's the service console. Go to instance. Alrighty. So let's go back to instance. Right, and with instance, locate the instance hosting your website and note its public IPv4 addresses. Usually found under IP4 public IP column. IP4 public IP column, right? Public IP column right here. Awesome. I'm going to copy the whole entire things. Go into text editor, so make it easy to work with. Okay. Awesome. So let's go back. Test website access. Open a web browser. Enter the following right here. Replacing the public IP with the actual IP I found. Oh, where is it? Right here. Copy it. Boom. It's just loading. Nothing happened. So I guess go back. If the website's load successfully, you're good to go. If not, proceed the next step. So it doesn't do anything. Just go loading. So go to the next step. Go to EC2 security group. So click on security group on the left hand menu of the EC2 service. Right, security group. Awesome. So what we're going to do next, select the security group associated with your instance. So which one associated with my instance? So this one right here, Cloud9 Cafe, associated with my instance. And what I want to do with it, after select it, then go to the inbound rule tab. Inbound rule tab right here. That's inbound rule. Awesome. Click on edit inbound rule, right? Add a new rule with the following details. I want to add a new rule Add new rule, so type would be HTTP. HTTP. Protocol should be TCP. Is default. I cannot change it. Port range should be 80 as well. Yep, I cannot change it. Source should be anywhere. For security reasons, consider restricting access to specific IP address or blocks if possible. So I would just choose anywhere in this case. 000 and click save. Awesome. Save. So Cloud9, go to Cloud9 environment security group, access the Cloud9 service, select the environment where your website is running, setting, manage EC2 instance, go to Cloud9. Where is it? Cloud9. I'm pretty sure that is this one, right? Select the environment where your website is running. Go to setting, gear icon, manage EC2 instance. Whoa. They don't have that. Let's go back and check. Access Cloud9 service. Cloud9 service. Yeah, let's go here. Check Cloud9 services. Probably just Cloud9, right? Go to manage EC2 instance right here. Manage EC2 instance. Click the security group tab. Alright. Click the security group tab. Edit the security group to add the inbound traffic as you did as for EC2 instance. Oh, it's not right here. It's not like that. Access the Cloud9 service. Select environment. Select the environment where your website is running. Select the environment where your website is running. This is environment, right? Environment. I selected where it's supposed to run. And then go to manage EC2 instance. Go to security group tab. It's all in here, right? Are you sure? Wait. Inbound rule. Yeah, it's here. I added. Checks website server configuration. Access your Cloud9 environment. Ensure that your website server software is running and configured to listen in port ID. Verify that the files on your main website's file is located in the correct directory served by your web server. How to do this step by step in AWS. So access Cloud9, go to Cloud Management, Cloud Service, go to where your website running, click on IDE button, choose allows the IDE in your browser, check if the website server is running. So open the terminal window in there, use appropriate command to check at the start of your website. So check startup of the website. Service could not be found. What about this service? Cannot be found. If not, start using sudo service apache to start. Fail start apache, it's not found. I cannot found. Oh, it's running right here. Awesome. It just say, yeah. Okay, awesome. It's running. Pretty cool. So okay, so right here that that thing is running. So it say hello from café web server. Awesome. So that is take care of. Let's go back. Our website is live. So no business requirement. Install a dynamic website application on the EC2 instance. Challenge 2. So in the previous challenge, you configured the EC2 instance. You now know that the PHP is installed and that the application environment has a running relational database. Also, the environment has a running web server that can be accessed from the internet. You now have the basic setup for hosting a dynamic website for the cafe. In the second part of this lab, you will take on this role of Sofía and install the cafe application on the EC2 instance. Awesome. For task 4, install the Café application, download and extract the web server application files in the terminal, bash terminal. Run this command right here. As you go to run it line by line. Go to our terminal again. All right, we go to environment. Good. Wait, what the hell? Unzip. Oh, we will unzip this. Unzip that. Okay. I think I have to run this line by line slowly. So this is 2 line, not 1 line. So, okay. Run. Unzip this. Awesome. Run this. Alright. Good. Awesome. So notice how the file browser now shows the 3.tar.gz files that you downloaded. You also extracted these archive files, which created the cafe, DB, and set up dictionaries in your work environment. Copy the cafe's files over the web server. Document the root in the bash terminal. We're going to run this command right here. Boom. Nice. Go back. Observe how the application is designed to work. So open the HTML cafe index.php source code in the AWS Cloud9 editor by double click it. So awesome. So what we need to do, open how the application is designed to work. So open the index.php in the HTML. Let's see. Whoa. Where are we right now? Let's see. In here, right? So HTML, go to café, right? Go to café, and inside café, we should go to index.php. Index.php. Right here. Boom. Awesome. So open the source code in here and double click it, and it's open. Then notice that this file has a HTML code in it, but it also contains sections that are enclosed in elements. These elements make calls to other system and resources. For example, on line 18, you see that the PHP code reference the file name get app parameter, that's PHP on line 18 right here. Open the get app parameter, that PHP is 5 in the code editor. Right here. Awesome. Open the get. Oh, so we already did that. Notice on line 3 of this 5 that the AWS SDK is invoked. Line 3. Okay, it's invoked right here. Also, on line 10 to 33, the web applications create a client that connects to the SSM service, which is AWS System Manager. The application then retrieves 7 parameters from the system managers. Those parameters have not been created in AWS System Manager yet, but you will do that next. On line 10 to 33. Here. We don't have anything here yet. So first of all, what we need to do is in the AWS System Manager's parameter store, gonna figure the application parameter in the bash terminal. We're going to run this command right here. Just run line by line to make sure. City setup. Awesome. So the shell script that you just ran is just AWS command line interface, AWS CLI command. This command added the parameters that the application will use to the parameter store. In the AWS management console, from the service menu, choose the management managers, right? So in the AWS service, we go to system manager, go back. System manager, right here. And from the left panel, choose the parameter store. Good. Notice how there are now 7 parameters stored here. 1, 2, 3, 4, 5, 6, 7. Good. The Café application PHP code reference those values, for example, so that it can retrieve the connections information for the MySQL database. Choose the Café DP password parameter and copy the values to your clipboard, and you will use this in a moment. Café DB password. Click it. Is the value right here? Let's go back. Choose it, and then click it. They ask me to click it. Choose it. Choose the parameter, and copy the value to your clipboard. Choose and copy the value. View detail then. I have no idea. This is the ARN. Okay. Amazon resources name. Maybe they meant this value right here. No. They meant the value is here. This is the value. Right. So I go to save this into my text. Go back. Now configure MySQL database to support the Café application. Back in AWS Cloud9 bash terminal, we're going to run those commands right here. So first of all, what we need to do is going to run the first command. the second, the third. Now we go back. Observe the database table that were created in the bus terminal. Run this command to connect the terminal-based MySQL client to the database. Enter our password. This is to be our password right here. Awesome. Welcome to MariaDB monitor. So when you are prompted to the database password, place the DB password parameter value that you copy. You should now see the MySQL prompt, which include that you are now connected to MySQL database that run on this EC2 instance. Yep. To observe the content of the database, specify specifically the table that support the Café application, enter those command right here. Very good. Now we exit out. Good. Update the time zone configuration is PHP. In the bus terminal, we'll run the following command right here. Awesome. So the first command that you ran configured the time zone in the PHP software. The second command that you ran restarted the web server so that the web server notices the configuration update. Very good. Test whether the Café website is working and can be accessed from the internet. So in the browser tab, try to load the applications at this address right here, where the public IP is the IPv4 public IP address of the EC2 instance. You will see that only the title banner of the website is low. The rest of the web page is not loading correctly. Okay. So what to do is go to choose my IPv4. Let me run it over there. Awesome. So we got our head page Café is running, which is pretty good. Awesome. Resolve any issues with the website. So in this step, you will need to configure out. We need to figure out how to make the Café websites function correctly. So here's a list of what it does. The test page is at low, so you know that the web server work and is accessible from the internet. You also know that the MySQL database is running and contain the table and data that support the application. So what could be the issues? There's nothing wrong with the PHP code reading. The issue is related to permission. Does the web application rely on any other services or resources in addition to the web server and the database? For example, does it require access to another AWS services? Go to IAM service and search for IAM row that is named Café row. Observe the permission that this row grant. Would it be helpful to have like this right grant to EC2 instance? How could you grant like these permissions to the Café applications? Last tip is like select EC2 instance in the Amazon EC2 console and review the options on the actions menu, and would any of these actions have issues? When you think you have fixed issues and load this page again, does it load completely so that you can see the Café menu item? So if so, congratulations. So it should look like something like this, I believe. And yeah, let's go back. So in AWS EC2 and Cloud9 service for a website. How to resolve the following. Oh no, it's not. Okay, update. Let's see. Let's see right here. So if we go to IAM service in the AWS management consoles and search for the IAM role, name café row. We go back here, choose IAM. And there's no user, no, oh, there's some row right here, cafe row, right? Go to cafe row. Examine the permission granted to this row. Check if it has the necessary permissions for the web application to interact with all the AWS services or resources. Consider granting these permissions to EC2 instances associated with the web server. What does it say over there? Now it's loading after I changed the IAM role. Awesome, very good. So after change the cafe row to our EC2 instance, now everything is running. So it's right here. So when you think you fix the issues go to this website right here, and it's loaded completely. If so, congratulations. So note, if you still can't solve the issue, you might find out it's helpful to run a gradient script as documented in submitting your work sections. At the end of these lab instructions, the submission report that is generated can provide additional tips for parts of the lab that you didn't complete successfully. You can submit your work as many times you like, only the score that you achieve on the last submission will be returned. So on task 5, testing the application. So test by placing an order in the web browser tab, where you have the HTTP with the IP address cafe page open. Choose menu. Okay, we're going to choose menu, and then submit an order for at least one of the menu item display. Notice that you may need to scroll down to find the submit button. Okay, so I'm going to choose one for this one, one for this one, one for this one. Total $7. We'll submit the order. Awesome. So we're able to submit the order. Thank you for your order. This will be available for pickup within 15 minutes. Very good. Awesome. So it's working. Now return to the menu page and place another order. Then go to the order history and to see the order detail for all the order that you place. Okay, what we need to do, return to the home page menu. All right, home page menus. Then we go to order and place another order. Okay, so I'm going to go to menu, place another order. So I'm going to order like 10 of this, one of this, submit order, and then go choose order history, and we do have order history up there. Very nice. So next task, new business requirements, creating development and production websites in different AWS region. Challenge 3. So everyone at the cafe is impressed with the new dynamic website that Sofía created. Customers are delighted that they can now place online orders and schedule dessert items for pickup. Customer satisfaction has increased because of the reduced customer wait time. However, another business requirement emerges. Along with the praise, Martha and Frank would like to have two cafe websites. One website that can be used as a development environment to mock up new features and web design before they are released to customers. A separate website that will host to the production environment that customer use. Sofía discussed the new requirement that Matteo when he came into the cafe one morning for his cafe. He suggested that ideally the two environments would exist in different AWS regions. Such a design would have the added benefit of providing more robust disaster recovery DR in the unlikely scenario when AWS regions become temporarily unavailable. Sofía is now very busy as she accomplishes more impressive work. Her skills become more in demand. Task 6. So create an IAM and an AMI and launch it another EC2 instance. Okay. So because the cafe website is already run well on existing EC2 instance, Sofía decided to duplicate it by creating an AMI format. She will then launch a new instance from the new AMI. You will continue to take on the role of Sofía for this task. Before you create an AMI out of this instance, you should create a new key pair, which might be important to have later in this lab. Set a static internal host name and create a new key value pair, a new key pair on the EC2 instance. So in the bash terminal, we're going to run the follow command right here. So first, we're going to run sudo hostname cafe server. Then run to the next command. Enter the passphrase, empty or no passphrase. So for the 2 times that you are prompted for the passphrase, press enter key. So we just press enter. Okay. To make the new key available to the SSH utilities in the bash terminal, we're going to run the following command right here. Awesome. So in the AWS Management Console, browse the EC2 service area and select the instance. Let me go to EC2 instance, go services, EC2 instance, we'll select instance. What are the new instances there? This is only one instance right here, so this one here. Okay, in the browse to the EC2 service area, select the instance. Now choose actions, manage and templates, accent, manage image and template, image templates, and create image. Okay, create image tips. Leave the create image dialog open in the browser tab while you answer some question about AMI. So answer your question about AMI. Answering will be recorded when you choose the blue submit button at the end of the lab. So return to the browser tab that has question for this lab you accessed earlier. So if you need to find the page again, to go to choose details menu to shows right here, choose access multiple website links up here on the bottom of the page. In the page, submit answers to following questions, question 5 to 7. Okay, so questions 5 to 7, so right here. So when you create an AMI from an instance, will the instance be rebooted? Let's see. In Amazon, AWS, when you create an AMI from instance, will the instance be rebooted? No, it's not will. It will not be rebooted. So let us choose the correct answer. When you create an AMI from an instance, will it be rebooted? No, it's not. It will not be rebooted. Next one, in what way can you modify the boot volume properties when you create an AMI from an instance? So I want to choose the correct answers and explain it as well. So in what way you can modify the boot volume property when you create an AMI from an instance? The correct answer is you can edit the size and delete on termination setting, but not the volume type. So here explanations right here. That the boot volume snapshot when you create an AMI from an existing instance. AWS taking a snapshot of the instance root volume to capture its state. This snapshot becomes the basics for the new AMI root volume. Right, and then multiple properties during AMI creation. You have limited controls over certain root volume property size. You can increase the size of the root volume for the new AMI. This is useful for accommodating more data or applications. Deleting on termination, you can choose whether the root volume should be deleted when instance launched from AMI or terminated. Multiple properties, so volume type, the volume type general purpose SSD, provisions IOPS SSD, magnetic, is determined by the source instance and cannot be changed during AMI creation. Is a fundamental characteristic of the volume that preserved in this snapshot. The key point is AMI creation allows some flexibility for customizing the root volume to better suit your need, but it's not a full fledged volume modification process. If you need to change the volume type, you typically create a new instance from AMI and then modify the volume type of that instance, or create a new AMI from a different source instance with the desired volume types. So the correct answer is you can edit the size and delete on termination setting, but not the volume type. Yep, so this right here, in what way you can modify the root volume properties when creating an AMI for an instance. So you can edit the size and delete the on termination setting, but not the volume type. So last question, can you add more volume to AMI that you create from an instance that has only one volume? So the answer is no, you cannot directly add more volume to an AMI that you create from instance that only has one volume. However, there are a few workarounds to achieve this result. Using manual attached volume, use block device mapping, use a custom AMI. So the key point is the limitations stem from the snapshot nature of AMI capturing the instance state at a specific point. While directly adding volume during AMI creation isn't possible, the outline workaround offer alternative ways to achieve the desired outcome. So the last question is no, you cannot add more volume to an AMI that you create from an instance that only has one volume. Pretty good. So I need to submit this. Submit, and then go back and submit. Go back. Okay, so just want to make sure I submit everything. 1, 2, 3, 4, 5, 6, 7. So that's total 7 questions that we have here to reinforce our knowledge. So back to the AWS Management Console in the create image screen. Create the new AMI. So image name could be café server. And choose create image. Image created. From the navigation menu, choose AMI and wait until the image status become available. The process typically take about 2 minutes, so you may need to expand images to file AMI. Let's see, let me go there. AMI right here. This take 2 minutes. AMI. Okay, so in here. Awesome. So let's go back. Create an AMI in another AWS region. So in this step, your objective is to create a new EC2 instance from the AMI that you just captured. However, you must create a new instance in the Oregon, US West to AWS regions. Where am I now? Okay. So in this step, your objective is to create a new EC2 instance from the AMI that you just captured. However, you must create the new instance in Oregon, US West EC2 AWS region. So now what I want to do is I'm going to stop recording, and I will start the next videos as part 3 for this walkthrough lab. So thank you everyone for watching. See you in the part 3 of this lab walkthrough. Bye bye.